When diagnosing an issue in an application, it's quite usual to come across a case where you find some unexpected value in a variable or data structure on the stack or on the heap. And you think, well, how did that get there? How did that value get into that variable? In UDB 6.9, Undo has introduced a new last command that enables you to work out exactly how that value got into that variable and to answer that question directly. So let's see how that works. We're looking at a small little demo program here, and it's at the point of crashing out because it's testing some invariant and the test is failing. We can look at those variables and we can see that the value it should be finding is 15, but it's actually finding 0. So we can use the new last command to work out when did that 0 get into that variable. And it's just a few lines earlier. So that's kind of how you use the last command, but it's a fairly simple example. Let's keep going and look at something a little more interesting. Now, the program that we're looking at is a small example of quite a common use case where you're populating some data structure in memory, and then sometime later you'll pull values out of that data structure. In this particular example, we're just populating square roots of numbers in a data structure called cache held in memory. Let's keep going back in time a little further, and here's the point where that value of 0 is being pulled out of the data structure. So this is the point where the incorrect value is coming out, but it's not the point where the data structure is being populated with the wrong value. So we can again use the last command to go back and find out when that variable, that value, made it into the data structure. So let's do that. And I'll use the last command again. And now we've gone further back in time, and this is the point where the value is being written into the data structure. So the last command enables you to directly answer that question of how did that value get in that variable. Those of you who are familiar with watch points will realize that it's also possible to use watch points for this same effect. The last command has two advantages over watch points. One is it's easier to use. You don't need to think about whether this is a location watch point or a simple watch point. The last command will just do the right thing. And the other thing it'll do is it'll notice when data structures or variables are allocated and deallocated on the heap and stop at that point. So if your data structure was created with the value that you're looking for, then it'll stop exactly at that point. In UDB 6.9, the last command is available at the command line, which is what we're looking at, for C and for plain old data types in C. In future releases, we'll be extending support for the last command for standard template library classes in C++, and we'll also be exposing it via the Visual Studio Code UI using our time travel debug for C++ extension.